What is going on, everybody? It is Kistner, and today we're studying 3.4 lesson in your student companion and in your book, and that is dividing polynomials. You should turn to page 74 of your book, page 74 of your student companion, sorry, not of your books, and we will get going. Now, dividing polynomials, there are two ways we're going to do this. The good thing is you already know one way. We're just going to throw in some letters. So the first way that we're going to learn how to divide polynomials is using long division. Okay, using long division. Now, long division is the same thing you learned back in elementary school. Long division of polynomials takes a little bit of time, hence the name, but it's not difficult. Okay, if you can factor, you can divide. So this thing, it says use long division to divide the polynomials. This is example 1 on page 74 of your student companion. Use long division to divide the polynomial, then write the dividend in terms of the quotient and remainder. Whew. Okay, so what we're really doing here, and the problem you're going to see is more like this. X cubed minus 6x squared plus 11x minus 6 all divided by x squared minus 4x plus 3. This is the same problem. So what we're going to do is we turn it sideways, and the thing on top goes inside. Okay, if you don't remember that, the thing on top goes inside, and it will be on the outside x squared minus 4x plus 3 all divided by, or all of this inside is going to be divided by that. So copy it down, x cubed minus 6x squared plus 11x minus 6. Okay, now, the way you do this is you make things match. Match and then subtract. I've said that before when we're doing systems, but that's what we're going to do here. I have to make this x squared, and all I'm concerned about is this first term. Make the x squared match x cubed. That's what I got to worry about. Make these two match. So what do I have to multiply x squared by to make it x cubed? I have to multiply it by x. X times x squared. Okay, x times x squared is x cubed. And now we just go ahead and distribute the x times everything. We did x times x squared, got x cubed. X times 4x is minus 4x squared, and it's minus because it was a negative 4. And then x times 3 is positive 3x. And now I subtract. I made the first terms match, now I'm subtracting. This is just like long division of numbers. X cubed minus x cubed is 0. That's what I wanted to happen. They cancel. That's what was supposed to happen. Negative 6 minus a negative 4. Be careful there. It's minus a negative. So negative 6 minus a negative 4 is plus 4. Gives me negative 2x squared. 11 minus 3 is plus 8x. And then negative 6 minus 0 is still negative 6. So now I have to worry about making x squared match negative 2x squared. So now we're matching this new thing. So I'm going to multiply the whole thing by a negative 2. Negative 2 times x squared gives me negative 2x squared. Negative 2 times negative 4 is positive 8, and that x stays. Negative 2 times 3 is negative 6. And what's really nice about this is everything cancels when I subtract. That cancels, and that cancels, so I'm left with 0. So my answer is x minus 2. So the whole thing, when you divide x cubed minus 6x squared plus 11x minus 6 divided by this denominator, your answer is x minus 2. It's right here. So that's how you do that. You make a match and then you subtract. Make a match and then subtract. We're going to talk about what happens when you have a remainder in a little bit. That's long division. It was really nice of your book to give you a pretty easy example there to start. We'll do part B in class. This is the new stuff, and a lot of people prefer this method over long division. Synthetic division. Synthetic division. This looks weird, but once you understand it, it goes by so much quicker than long division. It's the same exact process, but it goes by so much quicker. Okay, so use synthetic division to divide 3x cubed, 3x cubed minus 5x plus 10 divided by x minus 1. Now, we could do this using long division, but when a is 1 and it's a linear term, synthetic division is so much easier. So what we're going to do is imagine that this is in parentheses, and remember, I've told you, anytime it's in parentheses, when you take it out of parentheses, you change the sign. So what we're going to do is draw this little box like this and put the opposite of our factor in there. So this was a negative 1, so this is a positive 1. If this was a positive 1, we'd make it a negative 1, and so forth. We're going to put a positive 1 there, and then we put our coefficients of our x terms to the right. So I have 3 for 3x cubed. All right. Notice there is no x squared term, so I have to put a 0. This is like having x squared here. So this is my x cubed term. Here's my x squared term. And then my x term is negative 5, and my constant is 10. Now you won't see these written, but that helps me keep up with where I have this. So this is 3x cubed, 0x squared, negative 5x plus 10, which is what this is. Remember, this is 3x cubed plus 0x squared. There's no x squared term, but I have to have a placeholder for it. Minus 5x plus 10. So that's what I have here. Okay? This we won't see when we actually do the math on paper. So what I have is this setup. And this is what you'll always have for a setup. The first thing you do is drop the 3 straight down. Okay, you drop the 3 straight down. And you multiply. 1 times 3, you put the 3 here. Now, this is where it differs from long division. You add throughout here. Okay, you add. So 0 plus 3 is 3. 1 times 3 is 3. So 1 times 3 is 3. You multiply, and you add straight down. Multiply and add straight down. So drop the 3 straight down. 1 times 3 was 3. Okay. 0 plus 3 is 3. Okay, so now we multiply. 1 times 3 is 3. Negative 5 plus 3 is negative 2. 1 times negative 2 is negative 2. And then you add these, you get 8. Now there is no more numbers, so this is my remainder. Okay, so this is my answer. This is weird looking, but this is my answer. And remember, these numbers across the top were coefficients, so that means these are coefficients. And the way you write out your final answer here is you lower your top degree by 1. So this started as x cubed. When you drop it down, it becomes x squared. So this is x, this is nothing, and there's your remainder. So what I have is 3x squared plus 3x minus 2. Okay, so that's this. And this is the weird part of polynomial division, is how you deal with your remainder. If this was just a number, we weren't dealing with x's, we would say like remainder 8. You remember that from long division. But in polynomial long division, what we're going to do is add on 8 as my numerator, and I put it over what I was dividing by. So since I was dividing by x minus 1, I put that on the denominator, and this is my answer. So back here on example 1, I could have had plus 0 over x squared minus 4x plus 3, because that's what I divided by. But that's just 0. Okay? Anything divided by 0 is 0. Or anything, 0 divided by anything is 0. Okay? So remember, when you have a remainder, you have to put that x minus 1, or the remainder, over your divisor first. Okay. I want you to go back and make sure you can do synthetic division and long division. So I want you to divide these two. I want you to divide this into this. So I will get the setup for you. The setup will be this scenario. That's your basic synthetic division setup. And remember, that number that goes in here is the opposite of what you're dividing by. You're dividing by positive 2. So I'm going to put a negative 2 in here. Okay? And your coefficients. Okay, it doesn't skip an x. It goes 3, 2, 1 on your x's. So I'm going to put the coefficient of x cubed, the coefficient of x squared, coefficient of x, and the coefficient of my constant term. I want you to divide this, and I'll do the rest of it with you in class. But go ahead and drop the 1 down. Whoops. Drop the 1 down and start multiplying. I'll give you a hint. It starts off like this. Now go back, and if you have to, rewatch the last example and finish this out, and we will finish the rest of this in class. All right? I'm going to leave you, I want you to finish this, but I'm going to leave you with this picture. Okay? This should help. This is your concept summary. This should help. Okay? Do that. Make sure you've done your work for next class, and I will see you guys whenever. And this is Kitchener out.